Okay, come back to the original Zoom room, everyone. So we are going to start the roundtable session shortly. And now I would like to hand over the microphone to Professor Carla Pinto. And Professor Pinto is a highly influential, world-renowned researcher in the field of STEM. And I also want to extend a very special thank you to Carla Pinto today. She has joined us as both a moderator and a presenter in today's important roundtable session. Notably, we have invited esteemed scholars in the fields of STEM and AI to participate in this roundtable.
Hello, good morning to all. Thank you very much.
Good morning.
Can you hear me?
Yes, very clearly.
Oh, okay. So it's an honor for me to be here and to be an EVT here with you again. ICAS is a very interesting, in fact, it's an excellent conference. And I didn't know about it until, I don't know, a few years ago. And then gladly, I heard about it by Joe Plavixa and Christoph. So I'm really honored to be here and to be able to provide, some humble insights on AI in education, using AI in education. So as you know, I teach in higher education. My students are future engineers, okay? So I teach math courses to future engineers. And they need it a lot, right? Math in engineering. Otherwise, as I used to say, the bridges fall, right? Or as it happened once upon a time in the Tacoma city in US, so the bridge fell, and gladly nobody was hurt except for a small dog, poor animal that did not moved out of the bridge and fell. But nobody was hurt except for the cars. But without proper math, the bridges fall. The how do you say, the propellers? These devices that go to the moon won't be able to go to the moon because I don't know if you recall Ariane 5. Once upon a time, it was a satellite. So it was, I forgot the name. Oh, it was Ariane 5 was a rocket which was sent to the moon. The Europeans tried to send it to the moon in 1990 something, and what happened was that since there was not enough memory in the computers, there were numerical errors associated to the prediction of the trajectory, and so they had to blow up, so they had to destroy it because it wouldn't go to the moon. It would land somewhere else and could hurt people at Earth. Yeah, it's true. You can Google Ariane 5, and so everything. Thank you, thank you, Christos. And so mathematics is all over the place, and I really try to tell this to my students. But it's not only about telling them, it's about, how our students are nowadays. It's about showing them that mathematics is everywhere. And so mathematics is the basis of all of the other sciences, right? And so we need to be able to provide this information to our students and to make them realize that this is true. Because most of them, they ask, why do I have to learn integrals? Why do I need to learn derivatives? This is in higher education. So why do I need this? Why do I need to compute volumes? Why do I need to compute areas? Why do I need to compute velocities? So if you are able to teach them in such a way that they can actually see the usefulness of math in real life, then you grab their attentions, you can engage them, and you can motivate them to learn faster, I think, and deeper, because most of them also, they memorize a few concepts and then they forget about it the day after the test or the day after they use them, okay? As we all know. So my main goal as a teacher, and has always been, is to be able to engage my students in my class, and for them to retain knowledge after the class, after having me as a teacher, and when they go to the marketplace, to be able to use this knowledge. So I don't know if I can share some slides, because I wanted to talk to you about one of the projects I am coordinating right now, which is Math Bigger. It's called Math Bigger, and it is related to, let me just check where I put the presentation, because I was doing it yesterday, so it's here, presentations. Can I share my screen? Am I allowed to share my screen? I'm just asking, I don't know.
Yes,
yeah, I can do it. I can do it. I can do it.
Screen. Yes.
Yeah, I can do it. So let me put this in full in presentation mode. Is it? Oh, okay, good. Can you see it? Can you? Okay,
Yes,
so
we can see. Yes.
Okay,
Perfect.
okay, thank you very
We
much.
have about like 5 minutes.
Oh my dear God! So
Okay.
I'll move forward.
Good,
Okay,
thank you.
so my idea is to help students escape, like it's a math problems prison break. Okay, is to help my students evade math problems. Okay, so I know you know everything, all of this that I needed to to talk to you about. You know, our students are Gen Zers, you know, they like to participate, you know, that they were used and they were born in this new technology epoch. Okay, we weren't, but they were, and they like to always put their hands in practice. They like to learn by hands-on and by experiential learning, right? And so we also need to develop, it's critical to develop the soft skills in our students, which I call the essential skills, because without teamwork, without collaboration, without being able to be responsible and critical thinking about the problems that they are being posed, they won't be able to, you know, strive in the marketplace. This is getting technological advancement is perfect, is amazing, but it also requires more and more from us human beings, that we use them everywhere, not only in us as teachers, but also in other professions. So if they cannot do it, if they cannot work in teams, then it will be almost impossible to strive. So our students do not like this type of classes. They like better these ones. They like to be engaged more actively in their in their learning set. So in mathematics, we need abstract knowledge and we need applications, okay? And we need to have here the right balance between these two. So agile in education is what we try to do here in this Math Bigger project. It's related with math digital escape rooms, and what we propose to our students is to engage in a 3D environment. I will show you, if you allow me a few seconds. I will show you the 3D environment. And so we had to have this. These are the partners involved. So Jolt is here too, and we have a company which is Maxware. I won't talk about this. Why is this important? Why do I have zombies here in my presentation? Because storytelling, gamification is extremely important in every digital escape room to engage the students in order for them to solve the tasks and progress in the escape room in an amusing way. This is, for example, a future case study related to susceptible infections and recovered models. This is then you can ask me, how do students of differential and integral calculus understand these differential equations? They are in the first year, first semester, because you solve them by using the first derivatives, right? Differential equations, as we ordinary differential equations, are just first derivatives of equations, right, or functions, and so we use that to explain to them. And so why do we include videos in the case studies? Because we need them to engage, we need them to feel the environment, to be completely immersed, and to feel the escape room just like if they were in a 4D environment in reality escape room. So these are some photo of print screens, of the first escape room. So in the first escape room, they have to solve tasks related to solar panels, compute battery consumptions, etc. Let me see if I can go there. Oh, this is the website. 1 second. Can you see the other screen? Maybe not. 1 second. I need to, okay. This is
we have seen, yes.
Can you see this one? Where it is
just a
stand
second.
figure?
Yes, now we see your website. Yes. Perfect.
Okay, this is the website of the project. So the project will end in 31st January 2025. And so after that, we will put here the developed escape rooms, okay? But you can find more info about Math Bigger here. I just wanted to, just 1 second. Where is the presentation here? I just wanted to 1 second, to tell you that it has been quite an adventure. With us, you know, when you want to do to try to do something different in order to help your students, there are always challenges ahead. Don't think life is easy. I know in our age, at least in my age, we don't think life is easy anymore. Okay, and so we need to strive. And but I always remember this Rod Stewart song. I don't know if you know it, but I know it in my age. So Storming Waters, it's a beautiful song, but we should and will prevail, definitely. This is the Center of Pedagogical Innovation in which I work here in Polytechnic University of Porto. I am a co-coordinator, so I am related to the new innovation hub, which means that we are now creating a hub in which our students and teachers and colleagues will be able to develop new ways, not new theories, but new approaches to education. And I also believe in this always. In order to be successful, you will fail a lot of times, period. At least that's what I feel. And this one is fantastic, because I do think that if we manage to disappear from our students, then we did a very great job, okay? So you can reach me here in my email address. And I just wanted to show you a little bit, I think it's a 30 seconds video about the 3D environment of one of the escape rooms. I don't know if I can I?
Yes, please.
Okay, it's 30 seconds. I think you will like it. Just let me see where it is. 1 second, because I think you will how do I say, feel the 3D environment, and we will have 2 finished escape rooms. At least that's what the company promised us, and I think the students will like it. We are having some first. 1 second, I'm looking for that for that link. Oh, here it is. Okay, now I'm going to share my screen, if you don't mind. It's 30 seconds. Really, it's Math Digger, this one. Okay, so 1 second, reject all, and now, can you see it? I hope so.
Yes, we can see. Thank you.
Can you hear it?
Yes, we can hear.
Good. Okay, so you got a flavor. So in this escape room is the second one. The students will be able to build their own residence in faculty. Why? Because there was the storytelling is that there was a nuclear war. They hidden in bunkers, and then afterwards they got outside after everything was cleared, and then they started to rebuild everything that was.
Thank you so much, Carla, for sharing this interesting content with us. May I recommend you to put these links, including the video link, to the chat, so everybody can check it more thoroughly after the session. Thank you so much for the very interesting talk. And it's time to switch to our next speaker, who is going to be Professor Thomas Chiu from the Department of Curriculum and Instruction of the Chinese University of Hong Kong. Thomas is a great friend and have been several times on Stanford list of the most cited scientists. He's in the top 2% actually, due to his contributions related to AI and education. He is also involved in the Hong Kong AI curriculum design team. He's accumulated more than $30 million as part of various research projects, and is a very active scholar, and I learned already a lot from him through his publications, and also this curriculum. I think what's available in Hong Kong is a very unique one, because it's not only started with the AI boom, but it has many years behind. And I think there is a lot to learn for the rest of the world, that how to approach AI in schools. So Thomas, the floor is yours. You have about 20 minutes to go. Thank you so much.
Okay. Thank you for Crystal introduction. So I'm very honored that to share some of my work today. So I think it's very funny. Before I start, um, I just would like to talk about AI and STEM. It's very funny. People, scholar or computer engineering or educator, they want to separate them. AI and STEM, they are different. But for me, they are the same. They are similar, but just maybe AI because AI is interdisciplinary. They have a lot of mathematics, they have a lot of sciences, and also engineering. But they go beyond STEM education. Actually, in Hong Kong, AI is under STEM education. Just this is the background like this. And I've been publishing in AI in education, basically using AI to support STEM education. And I am also published paper that in AI education, basically teaching AI. Today the topic I think is a fundamental. It's very important to, I would say that to school, student, teachers, and even though I would say that higher education, the first step when you use, for example, I just want to give you some background before I move on. Um, um, when you use AI, we have to understand the AI first. Otherwise, because AI is we call it a destructive technology. So without knowing it, without understanding it, when you're using it, I think it's very risky because they just take anything that AI given the student, which is may not be good to education. So that's why I come up with today's topic because I was thinking, what can I do? So I show you some work, some hello. So I show you some product, or so I talk about anything, talk about fantastic tools. But instead of that, I would like to go to fundamental, the first step that how we plan, the integration of AI in education, because some teachers are hesitate, some students are may not willing to do that. How can we prepare that? So as you say, I would say that in AI or STEM education, I always want to clarify two terms: teaching AI, which is AI education. So there are a lot of people talk about AI literacy. So basically similar to mathematics literacy, similar to reading literacy. So we have PISA, we have Teams, this kind of big uh, assessment. It's more about knowledge. So, but again, understanding it doesn't mean that you can use the knowledge or AI in a productive way, healthy way, um, uh, safe way. It's different, understanding and applying in a productive way, safe way. It's different thing. So we should come up with another term we call AI competency. So what's that mean? That using AI to support learning and teaching. So this is different. We call AI in education. So now I just want to clarify that we have this. So I think that from literature, I think I would say that one of the first um, paper come out is from Lon. They actually define AI literacy for non-engineering. So for me, when I look at definition, it's very complicated because they have like a lot of like 17 competency, 15 design consideration. When I look at that one, because the background of Lon is purely engineering, he looked at this issue from an engineering perspective. When I talk to my some of the scholar that in Hong Kong, teacher in Hong Kong, and also in Middle East, and also Australia, even Europe, we found that definition is too difficult. I mean, too complicated, too technical, and then even the teacher don't understand, students don't understand. So that's why we drive off this one. And then also in the definition, they make use of the two terms, literacy and competency. They mixing it. But it's very funny. From Professor Gary Fallon from Australia, is a former editor of Learning and Instruction. That the journal is very, very top. And actually published one paper talk about they are different because he actually mentioned that literacy is closely linked to skill. It's about knowing it. It's the literacy should be measured by tests, and competency is different. Competency is a capacity to carry out a task effectively. That means that you you don't just use it. You have to use it in a good way, in a productive way. So it's very that these two of them are very different. Um, I'm sorry. So myself is so I work with some other scholar. We try to come up with the definition. So you can see the AI literacy we define like this. How you AI works and how they're using communicate with them in any setting, but it's about knowing it. So it's about skills. That means that can they use Google Teachable Machine? Can they use some apps to to identify some object? This is, or can they create some AI apps? This is about AI knowledges. Another one is we define. I think this is the goal because for me, AI competency is more important than AI literacy. Like for example, I understand English language, but when creative writing, I think is more difficult. So I actually this kind of like you can compare creative writing and also writing, which is a different thing. So again, myself, AI literacy and AI competency is different. So we add more to that. We add self-reflection because one of the things is AI, the knowledge. What we understand now about AI maybe change in 5 years, 10 years because of the, you know, AI is emerging. They are keep changing it. So what we understand now may not be right. So unlike mathematics or languages or sciences, it take years, even though they have a breakthrough, it may take like 50 years. But I mean, more likely they don't really change the knowledges or the application of that knowledge. But AI is different. So I think self-reflection is very, very important. I think this is, text, the definition. I prefer this one because actually this one is easier for you guys um, to look at it, what it is. And actually from the definition that technology is about what we they have to learn. They have to learn about the basic component of AI. So the impact, the impact is
Please go on.
it's about the impact of AI, which is very important, future of work, social goods, the risk, and also the ethical component, the principle. We suggest that there's so many because IBM ethical principle, like they have like 20 of them. So we sit down what are important to education, to student. We come up with 5 of them. So we list out here. So we also have to very important that the student must have a skill to communicate with AI. That means we always talk about critical thinking. Can they judge the if the prompt, the outcome that from generative AI are appropriate or not? So it's very important. The last one, we believe that it's very important. It stand out from digital literacy. We believe that they definitely need some self-reflection, which is qualitative and affective engagement. So this is the 5 component that we think that when they come together, they will become I would say that is a AI competency. So, and then, but how we can do that? How we can foster, later our student AI literacy and competency. So we did a literature review, systematic review. So you can see that we want to come out that there's a definition there. How can we do that? How can we uh, develop some pedagogy, or how can we develop some educational program to later student AI literacy and competency? And also we try to come up the idea that from literature, some evidence base, how to measure them. So this is the goal. That's why we come up with this systematic review. So to understand, because they have been doing AI in education, I think they start in the big wave is 2019. Everyone talk about it, but they have been doing it for a couple of years, 10 years. In Hong Kong, actually, we start in 2019, and in 2022, it became an official curriculum. So all Hong Kong kids have to learn AI in junior. It's the official document already, the curriculum. So everyone have to do that. So when it comes to this one, it's very funny. From literature, so how do they decide the content to foster AI competency? So most of them, from technology perspective, they talk about machine learning. I will say that because deep learning is kind of abstract. They mention it, but it's not. It's difficult for them to explain how AI works. Or news network, they will talk about it. They kind of understand, but they have to understand machine learning is the key. I think it's majority will doing this one because they actually can create it using different platform. I think Finland have their own machine, Google Teachable Machine like. I think Finland have to create their own one, which is very good. Collaboration is the second, component that we talk about. So the student must have a skill to communicate with the AI, but in this sense, we use C. That means computer vision. Can how AI see an object? How AI read messages? How AI write messages? How AI speak, like serial, something like that. How AI hear? This also is also serial, Siri. And then we also have to talk about think and create and reason. That is a generative AI. So in some of the literature, they actually talk about generative AI already. So and also reasoning. Then I think some study talk about there are 3 level reasoning that students have to learn, like rule-based, fuzzy length based. I mean, I'm not going to go to do detail, but in the third component, impact, they have to explain, how AI impact on society. But there are one thing that we focus is future of work and also social good. Future of work because it's related to the student. We believe that relevancy, the literature believe that relevancy to student relevancy are very important. So they have to talk about future of work, how they change their life. And social good is also another big thing that literature talk about it, because AI, unlike traditional digital technology, AI actually can, like for example, fake news, and then create, maybe plagiarism. So again, when they have to understand that AI, when they use AI, should be for social good. It's about their attitude. And ethic, of course, is very important there. I think many people talk about it. So AI cannot teach our student responsibility, but we can. So we have to do it like this. And then self-reflection, what we talk about, we focus on further learning. And you can see that when you come to here, we add one word called competence, because skill is not enough. We need our student to use it, not just use it. They have to feel confident. It's very important. So I think this is something that some of the literature mentioned that their attitude. So when you look at the chart, you can see that the percentage pretty much the first four components are similar. The current studies, they cover the first four components, but the self-reflection is something that they don't really not really touch on it. So I think we need more. How can we make sure that our students know that what they learn now at the moment about AI may not be maybe changing. Maybe they have to go revisit again in 5 years. This is very important. And then how they teach it, I think that it's also very important. So we go through all the article that we select. We found that many using this is the 5 major learning design, 5 major instructional approaches that the literature use. One is learning through experience. They use a lot of case study. They use a lot of uses. And the second one is design thinking. They actually engage. They create something for the community. And then contextual learning is actually is also very they actually using a lot of presentation, exhibition. Another controversial discussion actually is this a cultural? So this is more for ethic. And then the last one is because hand-on is very important, so they actually do a lot of I think majority using Huskyland or Google Teacher Machine. So the pie chart here, you can see that pretty much that they are very similar. So yes, just let me go through that one. Let me. So how they can be assessed? So in the literature, you can see that they pretty much using all type. So they're using tests, they're using self-reported, and they also talk about using rubrics to measure the project, and they also use classification. I mean observation and interview. So you can see that when the literature, when they look at AI competency, they actually don't think that it is a knowledge. They're using different kind of approach. You can see that not just knowledges, they're actually using different way of like I would say the 360 angle to measure, to assess this kind of student AI competency. So what I just talked about is the 3RQ that I just shared is the content, uh, instructional design, and also the measure. So this diagram summarize what I just discussed. So the middle one, the gray one, you can see the 5 components. In each component there are some sub-component, talk about describe each of the component. And then the top one is a assessment. The bottom one is the instructional design. So all come together to help our student to develop our student AI competency. Okay, let's move to the next one. So I would like to share a little bit more about how we measure, because I think it's very funny that I talk about 5 major ways of measure AI competency, but I want to talk a little bit, give you a little bit more about how actually you can measure it. So I want to go a little bit faster. So you can see that I just want to clarify a few terms. When you come to AI efficacy, it's about the belief. So usually we use self-reported approaches. AI literacy is more about knowledges. So similar to mathematics, I just talked about reading. Scientific literacy, usually PISA teams, they can do it. They use a lot of tests to do that. AI competency, I think, is a little bit different. We cannot use tests to do that. So what we can do, and then I want to give you some examples that we develop. You actually can use them to measure your student AI competency and test. I mean, this one. So the method is actually I work with different scholars. We use Delphi study. Anyway, move forward. I'll give you some tests. So when you develop your AI literacy test, because this is contextual, it always stick to your curriculum. It's difficult for you to use. I would say that, like for example, we develop some AI literacy tests, but it's aligned with our curriculum. So even though our test, I published a paper already in using psychometric analysis to validate our test. But our test may not apply to your country because we have different curriculum, we have different focus. But we give a guideline. We suggest that there are 3 dimensions that when you develop your own test. So you can see this is the 3 dimension. There's some question that you can use that for each dimension. For example, what is AI? They have to understand what intelligence is. They have to understand that AI is not a technology, not engineering only. It is a interdisciplinary domain. So it is the guideline that they can scholar or teacher can use. How does AI work? So there are a few questions that will also guide scholar and teacher that to do that. Impact is the same thing. So it is the test. So it is the recommended, I would say, framework that to help us teachers, scholar to develop their own one. Another one is we call AI self-efficacy questionnaire, self-reported item. So you can see that we changed a little bit. Because in school, student, their main job is learning. So you can see that we want to talk about learning. So we talk about support for learning. So can they use, not just use technology, can they use technology to support their own learning? So you can see that the first component is all about learning. The second one is comfort. Are they basically confidence? So you can see that they shouldn't feel, hesitate when they use AI. This is the second one. And then the third one is machine learning. I'm going a little bit faster. And then perceive easy to use. I think this is very common. But the data and AI is another focus that we believe that is very important because when I always say that data is a new coding. When we create AI, we don't need coding. All we need is data. So it is the thing that we think that is more important that in AI, measuring AI. So we stand it out. So the last one, so you can see that the last one is engagement in reflection, need for self-reflection. This one is echo to the last component of the AI competency. I would say that this is what I want to share, but this is self-reflective learning. You can see that the three domain, but we try to come up with some item that to help the teacher understand that what they are, other than we just talk about the sub questions. Yes, this is another format to talk about the test, but they let the student just do the questionnaire, open, semi-open. And for us, what can we use? What we discussed today. I think that we always say that we have a lot of different method, a lot of intervention. So we should, at the moment we have a lot of discussion. So I think we need more education program, more in intervention to evaluate the effective, because many people talk about it. What are the effectiveness? We need evidence, and also we need more curriculum. We need teacher education. This is the thing that I think that we should do. And I would like to have some advertisement because actually my new book coming up in 2025, January 3rd, will publish next in 2 months. This book is about empowering K-12 education with AI. In the book, actually, I talk about STEM education also, which is related to our conferences. They have step-by-step guidelines that to help us to integrate AI in school. Okay, I think I'm not going to talk about this one because I think I'm a little bit over one. So sorry for that. It's what I'm a little bit over one. Thank you for it's what I want to share. Thank you very much.
Thank you so much.
I'm sorry. Yeah.
For the very insightful presentation. I think we all learned a lot from the talk, and now it's time to turn our attention to Japan from Hong Kong. We have the pleasure to invite on stage Professor Hiromi Yokoyama, who is a key scholar from Tokyo University, and she's heading many projects, including also green AI related project and ethical AI, and the combination of sustainability and ethics is in her portfolio currently, but she's also very busy in finding out how to have more females in STEM and STEAM careers. So we are running this joint research project with Professor Yokoyama, and we had the pleasure actually to visit her like just a week ago in Tokyo, where she was heading the major science communication forum of Japan as part of the Science Agora event in Tokyo. So the floor is yours, Professor Yokoyama. Thanks a lot for joining us today.
Well, thank you so much for your introduction. And I will share my slide. Can you see my slide?
We can see that and we can hear you very well. Thank you.
Okay, thank you so much. So, nice to meet you, everyone. I'm Hiromi Yokoyama from the University of Tokyo. Today, I would like to talk about AI ethics research for STEM student education because I'm a researcher of sociology and I'm researching about the AI ethics. But recently, I'm very interested in STEM gender issue also. That's the reason why I connected with Christoph. And at first, let me introduce by myself. And I'm a professor at the University of Tokyo, and I belong to the Kawari Institute of the Physics and Mathematics of the Universe. The reason I graduated the physics department, and my PhD is come from physics. And after that, I changed my major, and now I'm researching about the science and society. And my research topics is very broad and the trust in science, big science policy, climate ethics also. But recently, I'm very interested in STEM gender issue and also AI ethics. So I have some lecture to the graduate students and about AI ethics. And today, I would like to talk about my AI ethics research because of I usually talk about my research itself to the graduate student in physics and mathematics department. And so that kind of specific research is very helpful to them to understand what is the most important issues in the real world. And so I would like to talk about it. At first, let's introduce the STEM gender issues. Now, the STEM women ratio is low, very low in Japan, and that's a very big social issues in Japan. And this is the model of the Cherian. She's the professor at the Washington University, and she prepared these kind of models, why lower representation of women in computer science, engineering, and physics. And they mention about the masculine culture of the field, insufficient early experience, and gender gap in self-efficacy. But we think for explain about the Japanese society, we had to add more one issues about the social climate. So inequality, social climate will be affect to that kind of issues, and we are now including this part. And they took data and analysis. And from last year, we collaborated with the Finnish researchers, including Christoph. And now we are now updating this model using the Finnish, UK, and Japanese data. And the next one is also the STEM gender issues. And as you know, high gender equality countries like Finland, Norway, Sweden has the lower women STEM graduates, and it's a kind of paradox. And the Korea is here, but unfortunately there are no data about the Japan. But we have now the gender gap index about each prefectures. Japan has the 47 prefectures, and each of them we have the gender gap index. So we now just started to analyze using this kind of 47 prefectures gender gap index and the comparison between the female ratio in STEM in each prefectures. So we hope to solve this problem. And these 1 years, we are very, hard to study about the AI ethics and publish many letters and the papers also. And as you see, we mention about the AI, especially generated AI, but most of them related to the medical issues. Why we selected about medical issues is very important. So we think so medical issues is the front line of the generated AI, and the students and also the our AI ethics researcher can imagine the difficulties very easily in that field. And how can I say, last year, this is the main newspaper, Nikkei papers, I mentioned, so what is the differences between the, previous AI and also generated AI? I mentioned 3 points from the social scientists. The first point is multi-point development. Not only the one university or one company, but the many companies leading the development is very different from others' technology. We social scientists have been studied about the technologies many years, and not only AI, but also the nanotechnology or genetic editing or that kind of things. And this kind of AI is very different from that point. The second point is very high-speed development, and the third one is worldwide simultaneous experience. So that's the reason why it is very difficult to precautionary principle. We are thinking this is very important for the society, but this kind of reason, from this kind of reason today, it is very difficult to thinking about precautionary principles. And the science in action is also very difficult things. So especially last year, every day we have the new news about the generated AI. So science itself is changing. So it is very difficult to educate about that to the student and also publics. And the last one is trust in AI. Trust in science have been studied a very long year. And as Thomas said, it's very difficult to educate about AI. AI knowledge is very complicated. But sometimes we can measure it. We prepare the 3 questions about AI literacy. We prepare about it with the physics scholars and check the literacy. Usually, Japanese people has the high literacy about AI, but they don't hope to accept AI technology in the society. So it's the very, how can I say, difficult situation in Japan. And so in this kind of situation, so these days I study about the AI ethics in medical issues and introduce about it to my students, graduate students. And from their report or discussion, so this kind of issues, the frontline difficult issues is very good for our students for thinking about it. And we have been developed the measurement of the AI ethics these years. And at first, we use this paper. And this paper analyzed the 38 guidelines from the world, AI ethics guideline. And most of them has the common 8 issues like this. As you see, privacy, accountability, safety, and security like that. And we call it octagon measurement. And using this measurement and they prepare some scenarios like that. AI singer, AI shopping, AI weapon, AI criminal. As you see, one by one, we prepare the scenarios, both of the positive aspects and negative aspects, including this scenario. And using this scenario, we measure the public's anxious level. And as you see, so this kind of level we can measure. And another things collaborate with the physicists and analyze AI ethics using AI. This is the decision tree analysis, and this is very simple AI analysis, and but using AI ethics, you are using AI and analyze the AI ethics is very challenging research for me. And we combine the United States and the Japanese data, and these data including the public attitude to the AI. And what is the most important branch their attitude. And as you see, so we calculated, and the country is the most important. It means the which country do you live is the most important things to decide the attitude of the AI. The second one is age. It means the elder people dislike AI, and the AI quiz is the third, and the more knowledgeable people dislike AI technology in this data. And we can check this kind of attitude in our data and developing the how to measure the AI ethics. And this is also the sample, but skip it. And recently, so I and my team are interested in the medical issues because the Japan is an aging society, and so we have to use the AI itself. But as you see, more than 30% public people already more than 65 years old. So it means we need to use the AI for the medical issues. But this is the one. This is another team result, and as you see, acceptance is very low. Another study found that only about 23% people agree to use the AI for the medical purpose because of elder people needs a medical care, but they don't hope to change their communication between the doctors and the medical institute. So it is a very difficult situation in Japan, and but we hope to measure the real situation using the medical issue scenarios. So science and technology always has the context. Not only do you like AI or not, this is not just, how can I say, easy question, but the set of the situation is very important. That's the reason why we use the scenarios, and we think so scenario is very important. And this time we prepare 8 scenarios about medical issues. The first one, drug discovery. Second one, medical diagnosis. And third one is clinical documentation, like that. And the 4 of them, more than 85% public people agree to use AI for that. The first one, drug discovery, and the second one, patient education, and third one is healthcare administration, like that. Sorry, 3 of them. Yes, the red one. Yes, so this kind of very specific scenarios about the AI is very important, and this is a very big hint for understand why public people worry about using AI. So this kind of research is always I introduce my graduate student. And the another one, measuring technology is we can do that. But of course, always there is a big limitation. And this is a very bad case, and and we wrote letter about that. And in Japan, child abuse is becoming increasingly this is a very big social issues. After COVID-19, especially increasing rapidly. So it means our government have to care about these issues, but the human resource is very, very limited. So our government hope to use AI to which children needs the help itself. And one researcher developed count the number of the which children needs real help or not. And this is the last year case. Very unfortunately, one girl, 4 years old girl, evaluated as 39% need for protection. And the government administrator thinks this number is not so high, so they don't care about her. But unfortunately, after that, she died by the child abuse. So this is very, I can say, big example, big bad examples. And what kind of assessment or what kind of communication did we need for that kind of cases. So it's a very important issues, and of course we need to use the AI, but especially for medical issues, we have to very care about how to use it and how to educate to the not only student but also who use AI itself. So that's very big, interesting for me last year. And this year, my team started about the green AI issues, as Christoph mentioned. And as you know, generated AI require very big electronic consume. So green by AI means AI can help the green governance and find some implication for the these issues, but at the same time, a new data center or using ChatGPT is consume big energy. So that is very big issues, and sustainable AI for AI for science. This is AI for science. So we are studying about the science and technology, and sometimes we use this keyword, sustainable AI for science is very important. At last, I hope to introduce this. And in our field, we have been mentioned about the hype issues. Some new technology sometimes expected more than real situation. And some scholars already mentioned about this is a little bit hype about this generated AI. I think so generated AI and the deep learning, machine learning, so AI itself have the very big power to change the world. But at the same time, so a little bit hype, I feel also. And if the hype is occur at once, the expectation is decreasing rapidly, and to keep the budget is very difficult. So we have to care about these things also, and I also tell about that to my student. And as you know, so this year is a very big year about the AI for science and the AI. And so now, from the perspective of ethics, we have to care about the sustainable AI. And also the production responsibility. Today, I have not so much about it, but we scientists have the very big responsibility about the production. And so it means the production responsibility have to be educated to our graduate students. So that's my interest. So my talk is very different from education issues, but I hope this kind of issues also help your interesting. So thank you so much. That's all.
Thank you so much for Hiromi Yokoyama for the insightful talk. I think again we have many different perspectives and many layers are considered in the roundtable and in the discussion. I'm very inspired by this variety of approaches. So let's even go beyond, and we have also Win-Kin Cheng from the Metropolitan University of Hong Kong, where we are sort of, may I say, some kind of colleagues, because I'm very glad to be a visiting researcher of the Metropolitan University of Hong Kong, where Win-Kin Cheng is currently teaching. And his project also related to use of AI, especially with mathematics educators, which been a very complicated issue for a while because of the nature of the generative technology, but he's also a book author. He has several very inspiring experiential math learning books, and also a great explorer of emerging technologies in STEAM education. So welcome on stage, Winkin Cheng. The floor is yours. Thank you.
Thank you, Christoph. Hi everybody, I'm Winkin Cheng from the Hong Kong Metropolitan University. Today's topic is about using AI for secondary mathematics remedial measures in Hong Kong. Actually, my project it is about how secondary school teachers use AI to help them in teaching secondary mathematics. This is a part of my study. And I think I would like to skip all those background and in my study here for this part, I recruited some secondary school teachers. They would like to explore some AI tool that can help them to cater for learner diversity, particularly for the remedial measures. And what I would ask the teacher to do is I invite them to use whatever AI tools that they would like, and they can choose the AI tools, they can choose the remedial topic, and in doing so, I asked them to try the best to capture the prompts with AI, how they interact with AI, how they can use AI to develop the material or help the student to learn mathematics. Okay, so now I just go straight to some of the results that I have so far. So the first one that I would like to introduce to you is this one. It is Magic School. So you can just use Google search. You can search for Magic School. You just need for most of the tools. You just need to use Google login. Then you can use those AI tools. And for this one, you can choose one core video setting video questions. This teacher, he select a YouTube link and then just ask the AI to generate some question based on the YouTube video. So nowadays, actually, I think there are lots of very useful, resourceful YouTube videos that help students to learn. All the teachers tried out flipped learning and blended learning. I think you can easily find some very useful video from YouTube. And you can see that based on the YouTube video, it can generate some questions. And also, if you look at the answer key, later on I would like you to try it out for some of those too. Okay. And you can see that for the answer key, it shows you which part of the video that you can find the answer. Say, for example, after 1 minute 20 seconds, you can find the answer for question 1. So you can have some answer like that. So it can help students to have some kind of self-directed learning. Okay, so this is one of the one of the material that teacher A showed me. And the other one, this one is called WebSim AI. So later on, I would also like you to try it out. So WebSim AI, the teachers would like to create 10-word problem using this WebSim AI, and it involves a linear equation in one unknown. And this teacher, he responded that he just need to use like less than 10 minutes to generate a set of exercise with solutions. And sometimes when the AI engine generates the solution, sometimes particularly for mathematics, there are quite a lot of mistakes. So sometimes we need to check the solution. So he suggests that we can use Copilot to check it, and also maybe you can use Grammarly to feed the questions to Grammarly, and it can help you to check the grammar. So you can see for the teachers, if he want to create some kind of work problem for the student for remedial measures, he can easily handle it. So this is some kind of AI competency that Thomas mentioned about. And now the next one. Okay, the next one is the Theaterize. This one, it is a paid AI tool, and it is quite sophisticated. It can answer you with some university level mathematics. Later on, I will show you how it works, and I think it worth the sum of money. So later on I will show you. And now this one, it is an example that a teacher showed me. He used the Copilot for social app. You can search for it. So you can just, it embedded in your WhatsApp. Okay, so you can take a photo. This is the student work, and the teacher take the photo and then ask AI, what's wrong with the student? Which can you identify the mistake from the student? And the AI responded to it. It identified that the mistake is in the second step. So it should be somewhere on the second line. Okay, and also he also tried out the other task. It is about some kind of integration, and again, the Copilot, it scan the image and then go through the solution, and it find out that generally the steps are correct, but in step 3 the student should simplify it before the student integrate it to get a final answer. So this kind of AI tools, it can really help the student a lot. And but sometimes, for this example, the teachers find out that the answer are not correct. So the AI generates some answer, but the response from the Copilot, it is not exactly correct. So when we are using AIs, sometimes consider a student using AI. He or she may not know whether it's correct or not, but if the student trusts everything that's given by the AI, sometimes he or she may be misled. And this is the teacher's C remark. So he suggests that Copilot cannot solve complicated trigonometric problem, but it can give correct solution after prompting. So for some of the tasks, after he or she ask the Copilot to check it again, it would give the correct answer. This teacher also tried out the Wolfram Alpha. Again, the Wolfram Alpha, he tried out the Pro version, which we need to pay for it. His results is that the Wolfram Alpha cannot identify the mistake, but it can give some correct step-by-step solution. So you can consider Wolfram Alpha is a very powerful math and science not problem solving, some kind of step-by-step solution. It can give you very accurate and good results. But Copilot, for the free version, the Copilot cannot identify the mistake made. And now this one, the next one about the photo math. I think photo math, quite a lot of students are using this photo math. What the teacher is doing is that he asks the student to finish the work. This is traditional way of assigning assignment, and then teacher mark the work, and then student do the correction after marking and after teacher explanation. So this is a traditional way that teachers would ask the student for the assignment. And now he tried it out with this photo math. He asked the student to finish the homework, and the student do the correction by themselves before teacher's marking. And the teacher marked both the student original work and the student correction based on the photo math. And he asked the student comment. All the student responded like good and convenient, and they will use this app again. And they can know the mistake right after they scan the result, and they can have the instant feedback. This is really important because sometimes if the teachers return the homework to students after a long time, they probably forget what they did. Okay, and they also say that, this is good because we don't need to do the correction. This is the student view. And here's some example. If you look at the first one here, the teacher shows this answer. Actually, the student write the solution, but after he or she scan the answer, scan the question, and the photo math give the answer, and he or she find the mistake, and he or she erase his or her original work and then just copy the photo math solution. And this is on the right side. This is another example. The student also write the original work on the left, and then the green one, the one that the student copied it from the photo math. So from these two examples, we identify that some students, when they use the AI, actually they don't really do some kind of self-reflection. It is what Thomas previously said about. It is really important that students and also teachers do some reflection when they are using the AI tools. And the teachers would suggest that the student, if they don't just copy all the answer, they compare the work from the his or her own work and the photo math solution. And if the student can find the first mistake that made, then it would help them to identify the mistake. This is what self-reflection or meta-cognition take place. And here are some findings. We can see that there are lots of very useful generative AI tools nowadays. But the problem is sometimes after the AI generates solution, we don't know whether the answer is correct or not. It depends on the teachers. And here are some consideration what we need to think about. It is about the choice of AI tools. So it is again a very subject specific, as mentioned by Thomas previously. And also how to ask AI questions. So it's some kind of prompt engineering, because for some novice learner, when they use AI, they just type one question and then wait for the AI to return the answer and take all those as the final answer. But very often, it depends on how you ask question. Okay, and also for the teachers' AI competency, I would also like to add something about this teacher's subject knowledge. Because if the teacher don't have the subject knowledge, he or she may not be able to evaluate whether the AI tools are giving a correct result or not. And so in our study here, we tried out quite a lot of tools. POE, Copilot, ChatGPT, Magic School, Jesus AI, WebSim AI, Theta Rise. This one is a paid one. Wolfram Alpha and also MathPix, those are the paid AI tools. And all those tools, I think they are quite helpful in the mathematics domain for teachers and also for students. And I think in order to evaluate the teacher's competency, I think we would look at this intelligent TPAC. So you can have some time to try out something. I would like you to try it out, see if you can use Magic School to generate 10 basic questions using this YouTube video. Later on, I will copy this page and save it to the chat, and you can try that out. And the other one is, can you use WebSim AI to generate 10 questions on grade 7 word problem on solving linear equations? So you can try them. Those are really very easy. You just need a Google login, and then a few minutes, you can get a set of questions that can help teachers, that can relieve quite workload from the teachers. And the next one, this is the task, and you can try it out how to set some questions and solutions on quadratic equation. And I would show you how we can get something that can fit teachers' need. And also, some teachers, they reflect that sometimes the AI engine, they can give the correct solution, but what the teacher would like is that they would like to have those mathematics symbol copy to the Word document, and then they can further edit it. So how can the AI engine help them to do those? Okay, so all those they are about some intelligent TKs, about the technological knowledge of the teachers. So if the teachers, they learn to use different AI tools, then they can encrypt this part. But in order to evaluate whether teachers they can use the AI efficiently and effectively, we need to also look at this intelligent TCK and intelligent TPAC. And now let me share this part to the chat. Okay, so you can try it out some, and in the meantime, let me show you some more example that we are doing with AI. So now this one, it is the MapPix, and this one is really very useful. So I just here's some example. I just scan some images. It would give me the mathematics symbols on the right side, and I can also export it to the Word document. So I can just use the symbol, export it as document, and you will then have the Word document. You have the Word document on the download folder. Okay, so it saves the math teacher lots of time, because very often we need to spend quite a lot of time in typing this kind of symbol. And let me see if there's some more example. This one. If you look at this one, actually, it is a writing here from a handwriting, and it convert to this symbol, and we can export it to a Word document. I think this one is a good tool that can save you quite a lot of time. And the other one that I would like to show you is that sometimes the teacher would like to generate some question like that, a set of question and the solution in this kind of format. But sometimes when you ask AI to do that, it would give you a question and then the answer with lots of explanation. But sometimes the teacher would like to have some very simple one in this way. So the top one is the quiz for the student, and the bottom bottom one are the solution for the student to do their own checking. So how can we do it? It is not that easy at the beginning for the novice teacher, and you can see that if you can use some kind of prompt engineering, so you interact with the AI tool, and then after you have some conversation with the AI tool, and then you combine all those all those questions, and you can then have some kind of simple prompt that you just key in this prompt and will give you some format that help to fit your needs. The other one, now this one, it is the WebSim AI. So what the teacher do is just type a question, generate 10 linear equation word problem, and it shows you all these. And this one, you can copy the URL, and let me send you the check. So you can do it in just like 1 minute or 2 minutes. So it is really very efficient. And this one, again, it is WebSim AI. So just the other prompt, and then you can set some question like that. Okay. Let's see. So this one, it is the magic school, So if you choose the set video question 2, then you key in the YouTube link, and then it will generate some question with the answer key, and you can see the hints from this part of the video. So these are all those example that share from the teachers, and I hope that this would enlighten you to try it out in your school. That's all for my presentation.
Thank you so much for Pinkin Cheng for sharing your insights with us. I think mathematics education and AI connection is a topic which interests many of us who are in the meeting right now. And we have seen a very interdisciplinary session. And now we still have a couple of minutes to discuss. So I would like to ask our roundtable participants to have their reflections or their comments to each other. Who would like to start? I try to pin every participant on the. Okay, Thomas is very eager to start, so please go on.
Thank you for all the quick talk. And actually, when I listen to all of them, actually, I think there are 2 points that is very important: culture and also discipline. We cannot just say AI, use it for all, because Japan have their own culture. So I think that, I think you develop a AI for science. I think, Japan or Europe, their own aspect. I think mathematics will be different from medical. So it's what I I can feel as a whole that it's very interesting. Yeah.
Thank you. Any other comments or any other reflections?
Can I say something, Christoph? So I think I've been written quite a lot in the chat, so sorry for that. I can be quite noisy, but what I would like to say is that we are still, at least that's what I feel, despite what it feels to us that we are already in a very high developed technological stage. What I feel is that we are really in the early beginnings of AI. I think we will have a lot of, we will still see a lot of things, a lot of development in our lives, but we really need to focus on what is important here. And the important part is that AI is here. AI has to be accepted. AI will be used, and it is already being used in our classes everywhere. In fact, so everywhere, that's everything that surrounds us. But the thing that we really need to remember is that we are the ones who made AI, okay? It's artificial, we are natural, we have neurons, we can think, okay? And this is only the beginning, because AI will be used everywhere, anywhere, everywhere, okay? And we will have, how do you say, a hard time figuring out what was in a few years, months, years, decades, trying to figure out what was really done by AI or by a human being. And probably that won't even be a question, you know, by then, that won't be a question. But we need rules, we need guidance, okay? We need to be extremely responsible right now. You know, being responsible, taking accountability for what we are creating. This is extremely important. That's my opinion. Thank you.
Thank you so much. Any others to add? Okay. So for Professor Hiromi Yokoyama, you wanted to unmute?
Thank you so much for all, Andy. So I enjoyed all of your presentation. And my institute is Physics and Mathematics Institute. So I have a question to Wing. So do you think in the future, so ChatGPT or AI is more powerful than the human mathematicians? So that's my simple question.
Yeah, I think nowadays the AI engine are very, very intelligent. They can solve lots of problem, but still there are quite a lot of problems that they are not doing quite well, particularly on the geometry and trigonometry domain. I still looking for some good tools that we can use. But if we talk about some calculus, integration, linear algebra, I think the one theorized, it gives very, and also the Wolfram Alpha, they gave some very reliable solution. And as teachers, if we keep prompting it and we can see different solution, I think it is important that teachers have different perspective, and they can look at different representation and different solution that can help students to build up their knowledge. And this is I think we need to equip teachers with such kind of belief and knowledge.
Thank you so much. I think that was a very good conclusion of the session, because actually all of you referred to preparing the teachers, and also broadening horizons, also ourselves as teachers and learners at the same time. So thanks a lot for all the roundtable participants. And now it's time to keep a short break. So we will have a break for 10 minutes from now. And we are expecting Dr. Andreas Scheleicher to be with us soon. So see you back in less than 10 minutes. Thank you.